What is the quotient rule in differentiation? Why do we need it? And what good does it make apart from the product rule? Well, if you haven't seen me simplify the product rule in just 5 minutes in this video, I recommend you go to this link. But I say in that video that anything a quotient rule can do, the product rule also can. Let's understand the fundamental of the quotient rule first. So a quotient rule is when you need to differentiate a quotient between two functions. But for simplicity, let's say we have a quotient of two functions, namely u and v now. And we want to differentiate, which is denoted by d by dx. So the rule goes like v du minus u dv divided by v squared. And note here that it is quite different to the product rule because the product rule would be u dv plus v du. So the key difference here with the product rule is that on top you would have a plus instead and it would be without the division of v squared. However you would like to remember it, make sure that you do not swap these two terms because the formula here for the quotient rule is that you need to start from the bottom term. So you see I have v kept the same and then differentiate u, and then minus u, which is the top part, multiplied with the derivative of v. Now let's have a look at some easy example. Here we would need to differentiate 2x over 3x plus 5. So again, the top part is u, the bottom part is v. So from the formula, this would be equal to v kept the same as 3x plus 5, du, differentiating 2x, we get just 2. So I'm just going to put 2 in parentheses there, minus, don't forget, this one is just the opposite to the first one, which is to differentiate the other term being 3x plus 5 now. Differentiating 3x plus 5, we get 3, and the other term kept the same, 2x, and then all divided by the bottom part squared. So that would be 3x plus 5 squared. If you want to simplify that, here's what you have. Now let's make it a little trickier. And here is where quotient rule will become apparently more useful. Because those of you who already know product rule, when you would want to make this applicable to a product rule, you would need to bring that third term up to the top and it would have a power of a negative fraction, which is a bit mind-boggling for some people and could make your working less smooth. Then of course, let's use the quotient rule. Again, let's bring the formula. So this would be equal. The bottom part is v, the top part is u. So bottom, square root of 3x minus 8 times the derivative of the top part, which is to differentiate 2x to the 4. Bringing the power of 4 down to multiply 2, I get 8. And then the power of x subtracted by 1, I get 3. Minus, so we got to differentiate the bottom part here. Now differentiating 3x minus 8 to the power of 1/2 would require a chain rule, which I already explained in the simplest way in this video, where you can go to the link up here. Don't forget to come back here. Now, if you're already okay with the chain rule, then let's carry on. Differentiating 3x minus 8 to the power of 1/2. So it would be bringing 1/2 down because it is the outermost function. So we bring the power down 1/2 and then we write everything as the inner part here. The power gets subtracted by 1. So 1/2 minus 1 becomes a minus half. And then we would need to multiply by the derivative of the inner function as well. So that means we need to multiply 3 outside here. And that is just the derivative of square root 3x minus 8. And the other part is kept the same, which is 2x to the 4. We write down. And all this is divided by the square of the bottom part. The square of a square root is just the thing inside. So that would be 3x minus 8. And that is the key result. If you want to simplify it, then you would get something like this. Now this one will be interesting. And we'll also discover some differentiation formula that we might already know. If you haven't gone through all the formulae, then I recommend you watch this video using the link up here as well. But let's do it. So using the quotient rule again, the bottom part keep the same first. We have cos x. Differentiating sine as the top part, we get a cos x minus differentiating a bottom part, which is a cos x. Differentiating cos, we get a minus sign. So I put a minus sign here in brackets. And then keeping the top part the same, we have a sine x there. And this is all divided by the square of the bottom part, which gives us square of a cos. Simplifying the top bit, cos times cos, we get a cos squared x. Minus times minus here becomes a plus. Sine times sine, we have a plus sine squared x, again all divided by cos squared x. Those of you who are already familiar with the trig identities, you can see clearly that the top part here is one of them. Sine squared x plus cos squared x would give you the identity of 1. So here we can rewrite as 1 divided by cos squared x. Those of you who already know reciprocal functions in trigonometry, 1 over cos is just called sec x. So here we have a square of 1 over cos. That means this this is going to be sec squared x. And that is why there is a formula. When you differentiate a tan, you get a sec squared x. We just proved it just by using the quotient rule there. Now that you might already have learned the 3 key rules in differentiation that would allow you to differentiate any kind of function on planet Earth. But the common question I get asked is, how do you know when to use which? If you've been struggling or wondering about the same thing, then I really recommend you go to this video right here. I'll see you in that video. Don't forget guys, keep studying. Bye.